Okay, this is our first tool, it's xaitMap. So xaitMap is there for creating navigation meshes out of geometry. Navigation meshes are data structures that you need to have your AI entities move around in a game. You have a game and you want to place soldiers in it, and those soldiers, they walk from one area to another. They need to know how to get there. And this is what you can calculate with xaitMap. What you do with xaitMap is you import geometry. In this case, we import buildings, we import streets, and we import terrain, which is everything but buildings and streets. And what we would like to do now is we would like to have AI entities being able to walk around in here, that they know their way, that they can get into a house, that they can walk from one house to another. So the next step with this tool, with xaitMap, is to define those characters, those entities. And I have two of them defined here. I have one character which I call small character here. He has a physical height of 1. This is related to the height units of this map, and a radius of 0.25. We got a tall character of height 1.5 and the same radius, for example. The radius of 0.25 means that the unit as a cylinder, it has a radius of 0.25. So it means that the unit is from one shoulder to another shoulder is like 0.5. It means that if you want to go through a door, the door needs to be 0.5. The next step is putting together the geometry with the people that should walk on the geometry. This is done in a NavMesh build, what you see here. So we got the NavMesh build. We say, okay, we would like to have one navigation mesh containing all the buildings, the streets, the terrain, and it should be valid for the small and the tall character. I would like to have it for the small character only. So before I go into details about these characters, I just show you what happens if I say it should calculate the navigation mesh, so that you see what all this is about. So I'm calculating that data structure that I've mentioned before. And now you see it all colored. What you see here, this is the navigation mesh. All those triangles now, those green and blue and brown, these are areas where the AI is now capable of walking. So you see that the AI can walk from here up to the stairs, into the house, and we go and look into the house, and we see that within the house the character can also walk up these stairs and go on top of the house. Right? So this is the navigation mesh, what you see here. Now what do these colors mean? As I've shown you before, we have buildings. I just switch them on and off so that you can see it again. Those buildings, we got streets and terrain. And each of these geometries has a different navigation mesh. They are all stitched together, but you can make different navigation meshes for different geometries. You use this, for example, I'll show you a demo later on, to constrict or confine movement to the streets, for example, where you say, I would like to have my people just walk inside of the house. So you need to tell your entities where they can walk, if it's buildings, if it's streets, if it's terrain. And this is why we have these so-called surface types. So the buildings have surface type building, and the navigation mesh is structured with the same approach. So everything which is green here is surface type street, everything which is blue is surface type building, and everything which is orange is surface type terrain. Now you can see that there are some buildings where there's no navigation mesh. For example, this one here, this building here. This is just because there's no door to getting in. Right? So here you can get in from the street, here you cannot get in. But how does the tool know that it should not calculate a navigation mesh on top of that building, for example. And this is done by what we call spawn points. You see a spawn point here. Do you see that red thing here? That red thing here is a spawn point, this one, and it's used to indicate where your entities can start, basically. So when calculating the navigation mesh using a spawn point, the tool deletes all the navigation mesh which cannot be reached from this spawn point. So if there's no navigation mesh on top of that building, it just means you cannot reach the top of that building coming from this spawn point. When there's navigation mesh here on top of the building, there is a connection from the spawn point somewhere up to that building. If I switch spawn point usage on and off, I'll show you. What I just did, I say, okay, don't use the spawn points anymore, and I recalculate the navigation mesh. You see that there's way more navigation mesh now. It's not necessary that the player starts on this spawn point. It just means that this is one level of geometry where the player starts. You could as well start the player here, or start the player here, or somewhere else, but all the level is connected to that spawn point here. Well, all the player, wherever you start the player, so I set the spawn point again to remove all this. New start. So wherever you place the player now on one of the colored surfaces, then he can reach everything else of the colored surface. And this is what the spawn point is for. If I move the spawn point over to here, or move the spawn point over to here, that's okay. It's the same result. Different. Yeah. The difference would be if I place it on top of that building, and you would just get a navigation mesh on top of that building. It's not necessary that the computer player really starts at exactly this point. He can start everywhere from every point which is connected to this point. Let's add another spawn point. And we rebuild the navigation mesh. As you see, here's one spawn point, the one I've used before, and I've placed the second point. So character starting here can reach just this page. I add another spawn point here, and I recalculate. And you see that players starting here can only reach this area. But it doesn't matter if they start here, 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 or here. Just everywhere which is connected to that spawn point.